In this video, we're going to talk about 2.3 Objective 6, where we solve applications involving techniques to compute limits. The magnitude of the electric field at a point x meters from the midpoint of a 0.1 meter line of charge is given by E of x is equal to 4.35 divided by x times the square root of x squared plus 0.01 in units of newtons per coulomb. That's capital N divided by capital C. Evaluate the limit as x approaches 12 of E of x. So we're going to make a substitution here. Since this function should be continuous at x equals 12, we can just go ahead and plug it in. And that would be E of 12 is equal to 4.35 over 12 times the square root of 12 squared plus 0.01. Trust you have your calculator and can plug that in. And we're going to round to 4 decimal places as needed. We get E of 12 is about 0.0302. A right circular cylinder with a height of 10 centimeters and a surface area of S square centimeters has a radius given by R of S is equal to 1/2 of the quantity square root of 100 plus 2s over pi. Close that square root minus 10. Find the limit as s approaches 0 from the right of R of S. So we should be able to stick 0 in there. R of 0 is equal to 1/2 of the square root of 100 plus 2 times 0 over pi minus 10. 1/2 of the square root of 100 minus 10 is 1/2 of 10 minus 10 is 1/2 of 0 is 0. So interpret your results. The radius of the cylinder approaches 0 as the surface area of the cylinder approaches 0. All right. Suppose a spaceship of length L sub naught, L0, is traveling at a high speed V relative to an observer. To the observer, the ship appears to have a smaller length given by the Lorentz contraction formula of L equals L sub 0 times the square root of 1 minus V squared over D squared, over C squared, where C is the speed of light, complete parts A through D. What is the observed length of the ship if it is traveling at 50% of the speed of light? So L equals L naught square root of 1 minus 0.5 C squared, or let's call this C over 2 squared over C squared. That's L equals L naught square root of 1 minus 1/4 is going to be root 3 over 2 L naught. All right. What is the observed length L of the ship traveling at 75% of the speed of light? L equals L naught square root of 1 minus 3C over 4 squared over C squared. So 3C squared over 4 is 9C squared over 16. So this is going to be 16 over 16 minus 9 over 16 is going to be root 7 over 4 L naught. Like that. In parts A and B, what happens to L as the speed of the ship increases? So we're getting a smaller observed length, so that decreases. Where'd that go? Number one, it decreases. All right. And then for D here, find the limit as the velocity approaches C from the left. And we're going to get L naught square root of 1 minus C squared over C squared is L naught of 1 minus 1 is L naught square root of 0 is 0. And what is the significance of this limit? As the ship's speed approaches the speed of light, the observer sees the ship seem to disappear. So that's E. That's it for this video. We'll come back next time and talk about 2.3 Objective 7. See you for the next video.